Okay, and so we're going to do, bit by bit, one at a time. That we're going to get through all of these, and just like last time, we're going to talk about the formula, and then we're actually going to put it into practice. So let's start with our first shape. We had a cylinder, right? There were two measurements that we could find for a cylinder. We had a cylinder. We had the radius, which was going from the point in the middle to the end. I think everybody here knows what the radius is. And then we also had the height of the cylinder. So the volume of our cylinder, the way that we calculate the volume is we determine what the area of the base is, and then we multiply it by the height. Well, the area of the base, as we saw with the surface area, is pi r squared, right? We have a base that is a circle, and to find the area of a circle, we do pi r squared. So we need to take our base, pi r squared, and then we just need to multiply it by the height. So let me do some color coding here. So H, oh, that's way too big. H was our green measurement, and R was hot pink. So just pi times R, and then all of that squared, and then times H. So let's take a look at some examples here. If we want to go down to, this is page 119. Page 119, this is question number 3 that we are working on for volume. So volume of a cylinder, once again, I'm going to write it here, is pi r squared times H. Again, page 119. So let's take a look at our first example here. We have this cylinder where we have two measurements that are provided for us. One of them is 8 meters and the other one is 22 meters. We only need two variables in our formula. We need an R and we need an H. Can anybody tell me what R is in this cylinder? What is R? R is the radius. So what is the length of the radius here? Awesome, it's 8 meters. Thanks, Deshaun. It's 8 meters. And what is H? What is the height of our cylinder? Or I guess in this case, it's like, the distance from base to base. Good, Mehek, it's 22 meters as well. It's 22 meters. So to find the total volume, we're just going to plug these numbers into our formula. Our formula, again, volume is pi r squared times H. So we're going to keep our pi, and I'm going to substitute in those two values. So I'm going to put 8 instead of r, 8 squared, and then times H, which is 22. Now, following BEDMAS says that we have to do exponents before we can do anything else. So we have to do an 8 squared. What is 8 squared? Good, it's 64. 8 times 8 is 64. And then we have times 22. So nice and easy here. We're just going to do pi times 64, and then again times 22. And I'm going to do that in one calculation. Pi times 64 times 22. And the answer here is about 4,423.4 meters. And is it just meters? Is it meters squared or is it meters cubed? Meters squared, or meters cubed? Do I put a little number above the M? What's the little number that I put? Good, David, yeah, it's meters cubed. Good, okay, so that's nice and straightforward, right? We identified what our radius was, what our height was, then we plugged those numbers into our formula and we solved. That's all really we needed to do. I'm going to give you a couple of minutes now. I'll give you 5 minutes to do the volume for the second cylinder when you're done with the first one. Okay, so 5 minutes to do that, and then we will take it up. Okay, folks, so let's take this one up. Let's take this cylinder up. So we have two different measurements here. So we have a 10 centimeters and we have a 12 centimeters. We always start by labeling what our variables are, our unknowns. So we have, we need an R and we need an H. Can somebody tell me what R is going to be equal to in this problem? What is R equal to in this problem? Good. R is going to be equal to 5. Nishan, why is it 5? I don't see a 5 on the diagram. Why is it 5? Good. The diameter is 10. The whole way across is 10, but we just need the radius. The radius is half of the diameter. It is from the center to the edge. The diameter is edge to edge. We have the center to the edge. So we actually have a radius of 5 centimeters. Good. And what's the height? H is, good. H is 12 centimeters. Good. Let's plug these into our formula. So we have the volume is pi r squared h. So it's going to be pi times 5 squared times 12. Okay. Now we have to follow our BEDMAS. BEDMAS says that we must do our exponent first. So we have to do 5 squared. That's going to be 25. So I have pi times 25 times 12. And then I can go and I can do, okay, I'm going to do pi times 25 times 12 in my calculator. And I get about 942.5 meters cubed. So the total volume here is 942.5 meters cubed. Okay, so that is our cylinder that we were getting started with. Nice and easy right off of the hop. This is wonderful, wonderful, wonderful. Let's take a look at the next shape that we're dealing with here. The next shape that we have is a sphere. Nice and easy. There's only one measurement for a sphere. A sphere just has the radius because the radius goes all the way around, right? So our volume, you can write the formula one of two ways. It doesn't matter. You could do 4 over 3 and then times pi r cubed. Or you could do 4 times pi times r cubed, and then that whole thing divided by 3. It really doesn't matter what you are, what you're putting there. And again, we only have one measurement, which is the r that we have. Good morning, Taha. No problem. Taha, we're doing volume, and this is on page, the formula sheet is on page 118. So let's now go to our, no problem here, I'll write it down. So page 118, that's the formula sheet that I'm showing on my screen here. Let's go down to a sphere problem that we have. Here we go. So this is on page 121. 121 right at the bottom. Determine the volume of each sphere. Round your answer to 2 decimal places where necessary. Okay. We recall the volume of our sphere. I'm going to write it over here. I like doing 4 pi r cubed all divided by 3. 4 pi r cubed divided by 3. Okay, so we have our first sphere is 10 centimeters. The first sphere is 10 centimeters in radius. That is the measurement that we have there. There we go. And so we're just going to plug in that 10 centimeters. So I'm writing a little note over here that R is equal to 10 centimeters. That's our radius. And we can find the volume. So the volume is 4 pi r cubed, all divided by 3. 4 times pi times 10 cubed, again, all divided by 3. We have to do our exponent first. Okay, our exponent is cubed here. So 10 cubed, we go 10 times 10 times 10, that is 1,000. So I have 4 times pi times 1,000, all divided by 3. I'm going to deal with just the numerator right now. So I'm going to do 4 times pi, times 1,000, which is, this is a big number. So we have 12,566.4 divided by 3. And once I do that, divided by 3, so 12,566.4 divided by 3, well, we get a volume of 4,188.8 centimeters cubed. So it's a huge number, but that is the volume, that is the amount of space that this sphere takes up. It is 4,188.8 centimeters cubed. I'm going to give you about 8 minutes now to do the other 2 spheres on your own, and then we will take them up, okay? Or just let me know. Let me know when you're done. I'll keep an eye on the chat, okay? Send me a message when you're done, and then we'll take them up together. Give me a shout in the chat when you're done, and we can take them up together. Alrighty, thank you, thank you. Let's take this up then. What did you get for B? What was your answer for B? $1.9, okay. Let's see. Okay, we have our volume formula. V is 4 pi r cubed, all divided by 3. We have a radius here of 4 meters, so I'm going to plop that in. 4 pi times 4, all cubed, and divided by 3. Well, if I do my 4 cubed, 4 times 4 times 4 is 64. So my volume is going to be 4 times pi times 64, all divided by 3. Let's just do the numerator. I have 4 times pi times 64, which is going to be 804. Let's say about 0.2. And need to divide all of that by 3. So if I divide it by 3, I get a final answer of about 268 centimeters cubed. So heck, I don't know what happened where you landed at a 1.9, but just double check some of your math there, okay? Just to compare it with
Oh, now I put in the calculator again and I got 804 again.
Oh, okay, that's better.
I think I put something wrong last time.
Yeah, you probably just skipped one. That's probably what I think what happened there. No, Nishan, it doesn't matter if you got 267. 267 is fine. As long as you're within a couple. That's all I'm looking for. So even if you got 270, that would be okay. Alrighty, let's do the last one here. So here we have 3.5 centimeters. 3.5 centimeters, we are doing, once again, our volume formula. V is 4 pi r cubed divided by 3. So 4 pi, in this case, r is 3.5. So I'm going to do 3.5 all to the power of 3, and then again divided by 3. Let's do the cubed. So there we go. 3.5 to the power of 3 actually gets me a bit of a decimal. So I'm going to write the full thing out here. It's 42.875. 42.875 all divided by 3. Let's multiply our numerator here. So I'm going to do 4 times pi times 42.875. I get about 538.8, which now I need to divide by 3. 538.8 gets me about 179.6 centimeters cubed. So 179.6 centimeters cubed. All right, so spheres, I think we can agree they're probably really easy, right? It's just a bunch of typing in your calculator. The formula is quite straightforward in terms of the letters that we have to deal with. Let's take a look at our next one. So the next shape that we're going to be talking about is a cone. So for volume of a cone, we need to multiply the area of the base times the height of the cone, so how tall the cone is, and then I need to actually divide it by 3. It's very similar to the formula of a cylinder, right? A cylinder's volume formula was the area of the base, which was a circle, and then times the height. A cone actually only occupies 1/3 of the space, right? Because you've got all this air on either side. So the formula for volume of a cone, I'm going to use this one over here, is going to be pi times r. R, once again, is our radius. It's going to be pi r squared because that's, again, the area of our circular base. I then need to multiply it by the height of the triangle. Oh, we don't have height color-coded here. Let's do height in red. So we're going to multiply it by the height of our cone, so literally how tall it is. And then I need to divide the whole thing by 3. So that is how you get the formula, or that is how you get the volume, of your cone. So let's do it. Pi r squared h divided by 3. And our cones are going to be question number 2 on page 121. So question number 2 on 121. I'm going to write the volume formula off to the side here. So it was pi r squared times h divided by 3. Okay. What is the R? We need an R and we need an H in this first cone. What is the radius of this first cone? What's the radius there? Good, the radius is 6. Perfect, the radius is 6. So we have 6 centimeters for our radius. And what is the height of the cone? How tall is this cone? Good, the cone is 8 centimeters tall. That's how tall it is. It's 8 centimeters. All right, we can go ahead and we can put these numbers into our formula. Volume is pi r squared h divided by 3. So I have my pi. I'm going to put my 6 squared, and then I have my height, which is 8, and I need to divide the whole thing by 3. So we're going to do pi, and then I have to do my 6 squared, right? BEDMAS says that you have to do your exponents first. So 6 squared is 36. And then I have an 8 along for the ride. And all of this is being multiplied. Afterwards, I'm going to divide everything by 3. So let's go ahead and let's multiply our numerator. So we have pi times 36 times 8. And that gets me to about 905. About 905. So if I do a 905 divided by 3, I get 301.7-ish. And that is going to be centimeters cubed. Okie dokie. I think we're in a pretty good roll with this, right? We're getting good at identifying the lengths of our unknown variables, putting them into the formula, and just continuing on. So I would like you to do B and C, okay? Once again, please tell me when you're done. I'm gonna give you about 8 minutes to do those guys. Thank you, thank you. Okay, so let's take this up then. In our cone B here, the yellow one in the middle, we have two measurements. Once again, can you tell me what the R is and what the H is? What is the radius and what is the height? R is 2.4, exactly. R is 2.4, that is the radius. Good, and H is going to be 4.7. That is the height right there. Good. Okie doke. Let's plug this into our formula now. So our volume is pi r squared H divided by 3. So we have pi times 2.4 squared times 4.7, and then that whole thing divided by 3. So if I take 2.4 squared, we have to do the squared first because of BEDMAS. So I have a pi times 5.76 is what 2.4 squared is, times 4.7 divided by 3. Now I can multiply all of my numerator together. So I can do pi times 5.76 times 4.7. That gets me to about 85, actually, almost 85 exactly. And we need to divide 85 by 3 to get our final answer. So if we go 85 divided by 3, you get about 28.3 centimeters cubed. Nice, okay. Let's take a look at our answer for C. What did you get for C? Somebody who did C, what did you get for C? Okay, 149.3. Let's see, Mehak, that sounds much closer than your last one was. Let's take a look here. So we have a radius and we have a height. What is the radius of our cone here? What is the radius here? It's 8, exactly, it's 8. So we have 16 is the full diameter. And then we have 8 is just going to be the radius. 8 is going to be half of that. So 8 is going to be our radius. And what is our height? What's our height, friends? Good, it's 2.9. You knew I was going to ask that. 2.9 centimeters. Good. Let's plug that into our formula. So our volume is going to be pi r squared times h, all divided by 3. Let's plug our numbers in. Our radius is 8, so we're going to do 8 squared times h, which is 2.9, and then divided by 3. We do our 8 squared first. 8 squared is 64. So we have pi times 64 times 2.9, all divided by 3. Pi times 64 times 2.9 is about 583.1. And I need to divide that all by 3. And Mehak, you were right. The final answer here is 194.3 or 0.4, somewhere around there, meters cubed at the end of the day. Woohoo! Very nicely done. Very nicely done. Okay, so we have done cylinders, we have done spheres, we have done cones, we've done everything circular. I think it is time for a break. It is just about 9:30. Let's come back together at 9:45, shall we? I'm just going to take a pause on this recording here.